Good morning, everyone, and good morning, web friends. Would all of you here turn off your cell phones or put them on vibrate before we begin? Dr. Raymond Marquis graduated in forensic sciences in the University of Lausanne, Switzerland, and received his PhD in forensic sciences in the field of handwriting examination, with experience in validating the fundamentals of this discipline through the analysis of character shape. Dr. Marquis also worked as a researcher in continuation of his PhD studies in the Institut de Police Scientifique, School of Criminal Justice of the University of Lausanne. In parallel, he has been working as a question document examiner for civil and penal and private cases. Dr. Marquis.
Good morning, everyone. See you. Oh, yeah. Got it. Thank you. Well, today I'm pleased to present the results of a study carried out in the University of Lausanne in Switzerland in collaboration with the University of Venice in Italy and Strasbourg in France. This study was supported by the Swiss National Science Foundation. In the field of handwriting examination, as you know, the assessment of handwriting evidence to determine whether a question text has been written or not by a given individual is mainly based on experience and training of the examiner, who gives a weight to the findings of the comparison process. The aim of this study would be to move from a subjective evaluation methodology to a more objective evaluation methodology. So we would like to develop a method that can provide quantitative support to help the examiner to give a conclusion regarding ridership. Of course, the idea would not be to replace the handwriting examiner, but to provide useful assistance with an objective support. Before the description of the model that we have developed, I just want to briefly describe the features that we have used in this research to characterize handwriting. So, handwriting samples were scanned at high resolution, and images of character A, D, O, and Q presenting a closed loop were submitted to an image analysis procedure to be binarized and then skeletonized. And then all branches that could remain around the closed curve were removed. The closed curve of each character was then described in polar coordinates, and this represents for each curve a periodic function that can be expanded in Fourier series. And so we obtain the fact that each curve can be described by a series of contributions, also called harmonics, and each harmonic is described by two parameters, amplitude and phase. And amplitudes and phases are called the Fourier descriptors, and these variables are used to describe the shape of each closed curve of the characters. For example, here you can see the first four contributions resulting from the analysis of a single character O that you can see at the top. As I said before, each contribution is characterized by two parameters, amplitude and phase. The first harmonic is represented by a one-leaf shape, the second one by a two-leaf shape. It corresponds to the elliptic contribution to the shape. The third harmonic is represented by a three-leaf shape, and so on. In fact, the phase of a harmonic represents its orientation, and amplitude of a harmonic is a measure of the influence of that harmonic to the global shape of the character. Here you have the stepwise reconstruction of the same single character. When you sum successively the harmonics, you progressively reconstruct the original curve. In our study, each character was described by the first four pairs of Fourier descriptors. These appear to be sufficient to describe the shape of the character's loops. The first part of the research was focused on characters A, D, O, and Q of a small population of 13 writers who provided samples at different days. General shape tendencies were proved to be common to different writers on this graph, taken from a discriminant analysis applied on letters A, D, O, and Q together of the 13 writers. Five main groups of writings are highlighted, and these are these groups. And this is an illustration of the shape of loops of the writers of these 5 groups. We can see that the separation between the groups is mainly due to the orientation of the elongation. In other words, the groups mainly differ in the second harmonic. In spite of these groups, discrimination was demonstrated to be possible on the basis of the 4 descriptors. We could show that each writer was characterized by a specific profile of character shape. So the collected data proved to be useful to contribute to individualize a writer. Thus, it could be possible at this point to imagine the development of an assessment model to quantify the weight of evidence that handwriting can be. The model was developed by Silvia Bozza from the University of Venice. This model was inspired from an existing model of Aitken and Lucy, which was designed for the evaluation of glass fragments. Their model was able to take into consideration the possible correlation between variables, but it assumes that the variation that you can have within a window is the same between windows. And this cannot be assumed in the field of handwriting because each writer is characterized by its own written variability. So we had to develop what is called a 2-level model, which takes into consideration the variability between the writers and the within-writer variability. To briefly explain the model, let's consider a case where we have a question text and the suspect is apprehended. We collect reference samples from the suspect for sake of comparison, and we extract 3 descriptors from characters taken on the question text and the 3 descriptors and characters of the reference material. And this value represents our findings or the evidence. And we would like to know if these findings support more the proposition H1 or H2, which are respectively the suspect wrote the question text or the suspect did not write the question text. And to answer this question, we can compute a likelihood ratio. The evidence or the findings can be written Y1 and Y2. Y1 represents the characters collected on the question text, and Y2 the characters data collected on the characters of the reference material. And based on previous results, we know that Y1 and Y2 can be assumed to follow normal distributions. And the likelihood ratio can be written as the ratio between 2 probability densities. When we compute the likelihood ratio based on a given number of characters taken from the question text and the same number of characters taken from the reference material, we have observed that the likelihood ratio depends on the draw. And this is due to the natural variation of the writing of any given individual. In order to take into consideration this source of variability, we decided to make different draws and to compute the likelihood ratio for each draw. So we obtain a distribution of likelihood ratios. Different experiments were carried out to test the model to check if correct values of likelihood ratios are obtained. I will show some results on letter A only, but similar results were obtained with the other letters, so D, O, and Q. In the first series of experiments, we compared the characters of the question text to characters of a person who indeed wrote the question text. On the right, you have examples of characters of the question and the reference material. In this scenario, we know that the proposition H1 is true, so we should obtain likelihood ratio values higher than 1 or log likelihood ratio values positive. As explained before, different draws were made, taking a number of question characters and the same number of reference characters. And here you can see the distributions of values of log likelihood ratios. We decided to plot the log likelihood ratio just to have a regular scale on the horizontal axis. And here, all the obtained values correspond to likelihood ratio values higher than 1, which is correct. So the correct proposition is supported. In the second series of experiments, the characters of the question text were compared to characters of a person who did not write the question text. Here again, on the right, you have examples of characters taken from the question and the reference material. And in this scenario, we know that the proposition H2 is true, so that the likelihood ratio should be lower than 1, or the log negative. All the obtained values correspond to likelihood ratio values lower than 1, which is correct once again, even if the shape for this particular example, the shape of the loops of the other writer do not appear that much different from the loops of the question text. In the cases I've just presented, the aim was to assign a value to a given item of evidence. So the likelihood ratio was used in evaluation purposes. But the likelihood ratio can also be used in investigation purposes. Let's consider a case where we have question text but no available suspect. So in such a case, it's not possible to collect reference documents and to evaluate the findings of the comparison between the question and reference material. However, the scientist could provide to the police information in support of more general propositions, such as the writer is a male or female, or the writer is a left-hand writer or a right-handed writer. This could provide useful assistance in reducing a given population of putative writers. Looking at the Fourier coefficients in males and females, a marked gender difference was observed for the variable B2. The distributions of this variable in the two populations, here for example for letter D, do not completely overlap, and this suggests that this variable can be used to discriminate the two populations. It was not the case for the other variables where the distribution between males and females were completely overlapped. The variable B2 is related to the second harmonic, which is, as a reminder, related to the elliptic contribution to the shape. So here the findings are a set of measurements taken on the question text, and the findings can be written Y. And to help to determine whether the question text was written by a male or female, we can compute once again a likelihood ratio. And the likelihood ratio can once again be written as the ratio between two probability densities, where H1 represents the proposition that the writer is a male and H2 that is a female. Let's consider the following steps. A set of 5 values of B2 of a writer are taken randomly from the population of males. We compute the likelihood ratio and we repeat this operation 10,000 times. This table shows the apportionments of likelihood ratio values obtained. We can estimate the error rates on the basis of these apportionments, especially if we sum the values higher than 1 and lower than 1. When H1 is true, I mean in cases where the B2 values were taken from the population of males, we obtain this number of values of likelihood ratio values that support the proposition that the writer is a female. So this corresponds to an error rate of about 35%. And if we do the same for the female population, we obtain an error rate of 19%. Now let's imagine a case. We get a question document, and we would like to know if the question document has been written by a male or female. And we extract the Fourier descriptors, we compute the likelihood ratio, and we obtain a value of 125. So we can stop here and just say to the police that the findings support 125 much the proposition that the writer is a male than a female. But we can precise something. For that range of likelihood ratio values, in 18% of the cases, we wrongly support the proposition that the writer is a female. And this represents the risk of misleading evidence. This is related to the robustness of the likelihood ratio. For the two series of experiments that we have carried out, the model was able to support the correct hypothesis. So the model is able to provide quantitative support for the assessment of handwriting evidence. But here, just be aware to the fact that the likelihood ratio values that we have obtained are only indicative, because the magnitude of likelihood ratio was sometimes often very high, and the magnitude of the likelihood ratio is indeed very sensitive to some parameters that need to be estimated on the basis of the background population, which was very small in this research. So some improvements are needed in this respect. In investigative scenarios, error rates in supporting the gender propositions indicate that the Fourier coefficients must be treated carefully. And now a software has recently been developed to make the whole process automated, from the image analysis procedure to the computation of the likelihood ratio. The model is not able to combine the different letters together, so we would have to develop a model that will integrate the within letter variability, the between letter variability, and the between letters variability. So we had to move towards a three-level model. The methodology will be extended to the analysis of open curves, and at the moment several other methods are under development and are almost ready to be integrated into the model, to the system. All of these developments are based on spontaneous and natural handwritings, and the methodology is now under evaluation for application in more realistic situations, in particular with simulated handwritings. And finally, I would like to say that the model is able to handle the complexity of multivariate data, and it's not specific for handwriting, so maybe it can be applicable to other types of evidence. And that's it. Thank you.
A couple of questions. Fourier descriptors are useful when you have closed curves, and I think you did mention at the end that you're going to extend it to open curves as well, right? I mean, your work was only about closed curves.
It will not be the Fourier descriptors, it will be something else.
Oh, you'll use something else when you make it. So different kind of features, basically. The other question regarding the likelihood ratio computation, you are actually using the joint probability of the two, the evidence and the known, and you're not using any kind of similarity or distance between the two, right? So, how are you able to handle the huge number of combinations that are possible in the full joint probability evaluation? Will that scale up with other features and so on? The principal use of distance is to overcome that huge problem.
Yeah, at the moment we are limited by the number of features that we have. That's also why we have used only four pairs of Fourier descriptors to limit the number of variables.
How many variables?
8.
Okay.
So 2 parameters by.
Okay. And you have enough samples on both sides, yeah. Okay.
Maybe you covered this with your stats, but I didn't really follow the stats too well. We are kind of trained that you really can't tell male versus female from looking at the writing, and you covered that. And I don't understand how you can differentiate male and female.
In fact, you can't.
You can't.
No.
And that's what your stats showed?
No, the data that we get can be useful to point towards the writer, but to separate two populations, left-handed writers, right-handed writers, or males and females, it doesn't work well.
Okay.
Raymond, sort of follow on from Dr. Shihari's comment. You did the 4 characters, A, D, O, and Q, all because they're circular closed, and apply a Fourier descriptor, and then you get your data. In the development of the LR, are you focusing on one character, or are you focusing on so it's single, and you don't have to worry about the...
No, that's why you had to develop a 3-level model to be able to combine the...
Then you got a covariance and interrelationship.
Yeah.
Okay, so it's not being dealt with at this point.
Dr. Marquis, we have an email question
Yes.
for you. What would be the use or applicability of this method when dealing with disguised or anonymous writing?
Yeah. At the beginning of this research, this was designed to contribute to the individuality of handwriting and not for practical casework. But now we'd like to see if it's possible or not. So a software has been developed, and a first version of this software is ready for about 3 weeks. So it's very new. We have proposed to students in their practical training to integrate this software. So they had to make the classical approach to give a conclusion, and then they had to do some measurements and to compute the likelihood ratio and to combine the 2 types of evidence, the types of evaluation. And their casework, or their case that was prepared, also integrates simulated writings. So it will be a first way to evaluate if this model can be applied with such disguise or simulated writings. But we have to make further research about it.
Yeah, I have a question. I understand it's preliminary, and it's looking at how you measure preliminary data. However, I'm thinking a little bit further ahead. In this case, you mentioned that this determination, or at least an estimation as to whether it's male or female, it's more for investigative purposes. However, let's look forward to maybe these are lay people, lay investigators that don't know Bayesian or estimations or the pitfalls. And even further, maybe in a court, in a jury. You mentioned that for that instance, the likelihood of it being a male is 125 times more likely. However, there's an 18% chance that there was an error in a misdirection, if you want to call it that. I'm sensing that would be a very hard thing for a jury or a layperson to understand, because when you say 125 times more likely, that sounds very strong for a layperson.
Yes, indeed.
And then you throw in 18%, which is a very large error rate. So I'm just pointing that out, and I was wondering if you might want to consider that and how you would testify.
I'm not sure I would say that we obtain a likelihood ratio of 125, and that this suggests, this supports the proposition watch one with a factor of 125, because there is no calibration of the likelihood ratio in that case. So even with that, I would be very cautious.
Thank you.
Thank you.